All right, good afternoon for problem solving. So we're going to start a discussion on chapter 5 today, and that is how to convert different units into other units. Okay, so we're going to start with imperial system, and then we're going to do some metric system, and then we're going to be converting from metric to imperial or from imperial to metric. Okay, so that's the gist of what we're going to be doing. I won't lie to you, there's a lot of problems here, but a lot of them are one-step problems. So even though there are a few, um, I've got faith you can get through it. Okay. I don't have all of these memorized, nor do I expect you to have all of these memorized. Okay. There's certain ones that I happen to know because for whatever reason. Um, but if you cook, you're going to know, like, well, there's what, three teaspoons to a tablespoon, that kind of a thing. So some of them you're just going to know, but I would definitely pick out the book, maybe bookmark the page or something to have it handy. And when you do your, oh, you know what, this might help. Okay, so this is in your book. You might, like I said, you might want to bookmark this page. Okay, have it handy. So when you take your quiz on this section, you will have some pieces handy for you to be able to do this. Because like I said, I don't, some of these I do know, some of them I don't. Okay, so and so I always get my else mixed up. I always think 5,280 or 5,820. I never get the two digits in the middle the same. Okay, it's got a little bit, the book actually has a little bit about some history of measurement systems. It's actually kind of neat. I don't know if it's in here or if it's somewhere else, but yeah, the whole idea that an inch is based off of the length of 3 barley corns is kind of a neat and quaint thing. So here we are doing space travel, and we are still right keeping our, well, an inch is 3 barley corns. Okay, but they came up with that in the Middle Ages there. Okay, so that's that's kind of neat thing, just the history of all the measurement we use. But yeah, that's not something I'm going to be quizzing you on. It's just the problems here. Okay, so part of me is very happy that I've always, this is like a thing you learn in chemistry, and I always rather liked unit conversions. Okay, I thought they made a sense to it. And when I learned this back in the 1980s, my chemistry teacher introduced it to me this way. And this is the way I've always kind of remembered it and learned it and dealt with it. So he would put parentheses in, right, to kind of set up, depending on how long it was. But he'd have these parentheses, and he'd draw a line through it because it's a fraction, it's a ratio, just like everything else has been. He said, "Oh, look, a TIE fighter." So we called this the TIE fighter method. And then during the 90s and the early 2000s, I would introduce this to this class and say, "Look, it's a TIE fighter." And everybody would look at me like, "What are you talking about?" So I was so glad that, later on, people started watching Star Wars again. So people know what TIE fighters are. So there you go. All right. So convert this. We have 4.75 feet into inches. Okay. So what we're going to do is we're just going to set this up this way. We're going to 4.75 feet. Whatever you're starting with. I mean, if you have miles per hour, the bottom's going to be hours. So it's just be 1 hour here. But in this case, it's just feet. The only thing on the bottom just goes to be a 1. Okay, we draw a little parentheses there. And they want to convert this to inches. Okay. Yeah, we want to convert to inches. Okay. So I know that there are 12 inches to a foot. Okay, and now we're going to pretend that the feet actually mean something as a variable, or mean something like a number, where we can cancel out the feet, and then we're left with inches. I would suggest doing something like this for every problem you're going to do in this situation, because you won't get them backwards, you won't get them mixed upside down. I don't want to do that. Okay, there we go. So you never get them backwards, you never get them upside down. You'll be left, check. Like, oh, I've only got inches left. Is that what my answer is supposed to be in? Yeah, that's what my answer is supposed to be in. So that's how we're going to go ahead and do that. Okay, so there we go. Have some more freedom here. Get off my leash. So 4.75 times, oh, what turns it on? So 4.75 times 12 inches. Okay, and we get 57, and then inches is the only thing left. And that's how we convert. Some of these are going to be a little bit, they're going to go a little bit easier, a little bit faster for you. You might be a carpenter, you might have more expertise in a particular area. That's fine. Go ahead and use that. Okay, but there we go with that. If you don't have it, or if you're like, this always bugs me, this is a method for you to do it. And it works for English units, it works for metric units, it works for everything. So yeah, and there's 20 problems in this section. So I'm going to skip around a bit. Okay. Again, some of these I just don't know. So we have 1,500 yards equals how many miles? Okay. So what we're going to do is we're going to take 1,500 yards. It's not a beginning ratio, right? We don't have a miles per hour, right? Or density thing like pounds per volume. Okay, so we just put in a 1 here. Okay, and then, well, we got to go to miles. Okay, so what's going to happen with miles? We're going to go check out our text. We have 1 foot, we have what, feet, yards to feet. We have rods to feet. I don't know what a rod is. And we have miles to feet or yards. So I know that there's 1,760 yards per mile. Okay, so there's 1,000, just write it, 760 yards per mile. Now, can I cancel the yards? No. If I multiply this together, we'll have yards squared over a mile. That's not what we want. Okay, so this would be the wrong setup. So what I'm going to do is I'm going to swap it and fix it so the yards cancel. So I want 1,500 yards. Leave this one alone because it's what you're starting with. It's the conversion factor here that got messed up. So this is 1 mile, but 1 mile is the same thing as 1,760 yards. Now look at the yards. Now they cancel and we're just left with miles. That's exactly what you want to do. Okay. So we're going to have 1,500, then divided by the stuff on the bottom, divided by 1,760, right? So we're going to end up with, I have to look at what they want their answers in here, but 0.852. So we're going to say 0.852. Okay, and what do they want? They want this in round to the appropriate number of significant digits. Okay. I thought this was later in the course, but I guess not. Okay, how many significant digits are there? There's 2 here. Okay, there might be 3 and 4. There might be. This does not count because this is the definition. So this does not count in your thing. What you're looking for is the 2 people here. And I'd say that this is a little ambiguous because there might be 4 significant digits here, but I think there's just 2. Okay, so we have 0.85. I'm willing to be wrong. Okay, no, I wasn't. Okay, what I mean by this is ambiguous because these two digits are zeros. That's not giving me any confidence that somebody actually went out and measured what the 10s and 1s place were here. So there's a big difference between 1,500 and if you say 1,503 yards, this has 4 significant digits, 1, 2, 3, 4. because there's a thing in the ones place. But this one, right? I mean, if I look at the time right now and I say it's 3:15, right, down here, it's 3:15. All I could say is I probably have one significant digit. It's or two significant, well, be three, but I've got 3¼ hours. I don't have 3.26 hours. Okay, not 0.26, but 3 hours. And yeah, maybe a little bit more. So if there's a digit here that's non-zero, okay, then you can kind of look at it and say, well, there's definitely something that was measured here. If it's not zero, you can say there's something measured here. Okay, but if it's just a zero, you can't really be sure. So I'm going to err on the side that somebody did not measure out the 00 here, because it could have been like 1531 yards. But you know, if you measured long distances, right, you already know it's like, well, it's 15 yards. It's 1500 yards rather. So if you're a runner and you say, I'm going to run 5K, and somebody asks you and they say, well, how long is that? It's about 3 miles. Okay, I mean, it's like closer to 3.1, but you're not going to go, you don't expect the person who did the race to measure it down to the inch. Okay, so if I say it's a 5K, you've got one significant digit, 5. Okay, so you could say 3.1 miles just to be a little bit more accurate, but it's about 3 miles and you're not hurting anybody. Okay, I'm not even a very good runner, but I'm not going to begrudge somebody 0.1 miles. At the end of it, I don't run marathons, so I've never thought to do that. I might feel differently if it's 26 point something miles versus 26 point, like one more of those miles, 26.2 or something. I might begrudge them for 26.3, but I don't know. I think we do more significant digits and scientific notation a little bit later. Okay, 84 quarts is how many gallons? So we have to do 84 quart, again, over 1, because I'm not doing like any kind of ratio, like miles per hour is a ratio, it's miles per hour. Okay, and then to how many gallons? Well, I've got to find out. It's like, well, how many gallons are there in a quart? You might know, but you know, we have liquid capacities here. So we have quarts to gallons. Is that what we have? Quarts to gallons. So we know a gallon is equal to 4 quarts. Okay, that's very easy to deal with. Okay, so 1 gallon is equal to 4 quarts. So notice the quarts cancel. We're left with just gallons. Okay, so we have to do 84 divided by 4. So, well, how do I know if this goes on the top or the bottom? It's 4 quarts to a gallon. So whatever number here to the conversion, that sticks with the unit that it's converting. Okay, or converting from. So we're just going to go off and say we've got 84 divided by 4. So we've got 21, I think. Yeah, 21. So this is 21 gallons. Okay, so that's what we're doing here. And as long as you stick with that, you're going to be just fine with all of this. Okay, so this was 21. Oops. Well, like I said, they're not going to always give you nice values, and I don't know. I know that when I was looking at these before, there were some things that were in bushels. I don't know what that is, but ton. Okay, 14,840 square feet into acres. Okay, so we have 14,840 square feet divided by 1. Now your book is very nice to you. They give you what you need to do all of this stuff, but I want acres on top and I want square feet on the bottom. Okay, so we're going to go off and say our e-text, length, weight, and liquid. It's not here. So I know elsewhere in the values that this is going to have areas. I know they don't make you do that, especially with something like an acre, because I have no idea what that is. There we go, area units. Okay, so feet to square inches. Okay, we have square yards to square inches and square feet. Rods, square rods. To figure, an acre is 43,560 square feet. Okay, so 1 acre is equal to 43,560. Okay, so what we're going to do is we're going to put we want the 1 acre on top, right? 1 acre here, and we want 43,560. Okay. I had a friend who worked at a hardware store in the rural area, and a lot of times people would come in and ask them for fencing for an acre. Unfortunately, acres do not have a length or a width sort of requirement. It's just an area. So you could get that as an acre, or you could get this as an acre. So we'd ask. I don't know. So he'd sell them the fencing for that one. Okay. Because he sold more fences that way. But so yeah, if you have an acre, you have a value you want to go, you want to measure this and this, okay, before you go in and ask for fencing. You want to know what is the perimeter, what is the boundary measurement. Okay, so we got 14,840 divided by 43,560. Yeah, I think they just most of the time they just do this for us. So let's see, how many decimal places do they want? Are they going to leave it up to us? Type a whole number, decimal, round to the appropriate number of significant figures. So here we have, right, we have 14,084, or 840. So we have 1, 2, 3, 4 significant digits. I don't know if this was really a 1 or not. So I don't know what kind of digit that is. I think in this case, what they would do is say 14,840. And if they wanted this ones place to be significant, they would put a dot here, right? Because it's like the start of a decimal place, but they didn't do that. So we have 1, 2, 3, 4 significant figures. Again, we don't count the conversion factor. These are defined values. They were not measured. When we're looking for like how many significant figures, it's like, what did you measure this to? Okay. So like in statistics, we talk about weight, 2, 3, 4. So it's 34.0. This 6 is going to raise up to a 7 because the 7 is going to push this one up a little bit. So this is 0.3407. So this is 0.3407. And it's a little bit weird because with the weight, people round to the nearest 5, right? So if you're going to set things up with statistics, you would want the 5 values, the zeros or the 5s, to be kind of in the center, and you would make your little categories around it, because if somebody weighs like 156, they're going to say 155. Okay, it's normal. They're not lying. It's just that's easy to figure out for us. Okay, so you just have to be a little bit careful with that. Okay. Should probably want to do more of those. No, in this case, round 1 decimal place. Okay. Okay, so let's see. A mountain incline climbs from an elevation of 6,555 feet to 8590. In this case, I would say there's 4 significant digits because this first number gave us 4 of them. And even though I would usually be uncertain about this because this one had 4, I'm guessing they took the took the value to measure this one out to the ones too. Okay, fastest reporting time up the incline is 17 minutes and 42 seconds. How many vertical feet per second did the mountain climber climb during his record-breaking performance? Okay, we can't deal with minutes and seconds at the same time. Okay, just like when we deal with fractions, like I don't want a mixed number, I want a whole number, or an improper fraction. I don't want to deal with like 4 1/4. I want 17 quarters. So what we're going to do first is we have to convert our minutes into seconds. So our first step here, we're going to convert minutes to seconds. Okay, so I don't have to look this one up. We have 17 minutes divided by 1, and then there are 60 seconds into 1 minute. Okay, you probably already knew this. So that's what's going to cancel. We're going to end up with just seconds at the end here. Okay, it's always nice to verify a thing that you already know how to do with something that's a little bit different method. Okay. Times 60. And we get 1020. So we have 1,000 seconds. But there was also like a 42 seconds later on. There's also a 42 seconds. So I'm just going to add that 42 to the 17 minutes here and get our value. So we're going to have 1,062 seconds, right? Now, the next thing we have to do is we have to figure out the difference in sea level that we have, okay? So we have 8,590 minus the smaller elevation, okay? So we're going to get our 8,590 minus our 6,555. Okay, I'm not gonna be lazy about this. So this is 8,590 minus 6,555. All right, and that's, we ascended, or this person ascended, I didn't do anything, 2,035 feet. Okay, 2,035 feet. Okay, that sounds a little bit weird. The and is where you put the decimal place. Okay, so that's something I try to deal with. Okay, so this is in feet. So they want to know how many feet per second. Well, that's 2,035 feet in 1,062 seconds. Okay, and that should be our value. And they said round to 1 decimal place. Okay, so 2,035 divided by 1,062. Okay, so round to 1 decimal place, this will be 1.9 feet per second. I don't know if that's, I mean, clearly it's fast. You broke a world record for this, so, or this mountain climber broke a world record for it. So that's, okay. So this is 1.9. Okay. All right. So we're getting a little bit more into the practical questions here. I'll start doing some stuff. Okay, a machinist must cut 12 strips of metal that are 4 feet, 4 7/8 inches long. I don't think I understand what they want here. What is the total length needed in inches? Did they just want me to convert this to inches? I think so. I'm willing to be wrong though. So we have 4 feet and 4 7/8 inches. Okay, so I don't have to convert inches to inches, it's already there. So we're going to have 4 feet. I don't have to look this one up either. We have 12 inches per foot. And if you have to look it up, then look it up. It's okay. I'm not going to judge you. Okay, so that's 48 inches. I'll never know. Okay, so you're completely safe. We have to add 4 7/8 inches to this. What is 7/8? We're going to change that to a decimal because I have a feeling that's what they're going to want. So that's 7/8. I think it's 0.8. No, it's okay. 875. Okay. So this is 4.875 inches here. And all we're going to do is say 48 plus 4.875. Add those together, we get 52, because 48 and 4 is 12, so carry the 1 there. So that'll be 52.875 inches. And I hope I interpreted their problem right. Okay. Tell you what, we're going to try. No, we're not. 52.875. Oops. Okay. Check our answer. Total length of measurements. This is so helpful. When I wrote the problems for this myself, I was like, wow, they don't have. Oh, we need the number of strips. Okay. Thank you. That was helpful. How many strips do we have? We have 12. So times 12. Looks like a job for a calculator. Okay, so we have 52. 52. I could have just answered in 52.875, but we're just going to multiply this by 12 and hope for the best. Okay, so we actually need 634 point. I'm glad I changed it to a decimal because 12 times 7/8 doesn't strike me as a lot of fun. 0.50. Okay, 634.50. 634.50 inches. That looks better. All right. So let's go ahead, take a look at 18. Okay, actually, I'm going to pause you for a moment to see if somebody rang the bell. All right, there we go. Nobody important. Okay, so suppose a hybrid automobile has an average fuel economy of 60 miles per gallon. That's pretty big. And non-hybrid averages 20 miles per gallon. That's not so good. All right, the hybrid model costs $6,000 more than the non-hybrid. We're not assuming repair costs or anything else. We're just going to do a very simple calculation here. Gasoline averages, that's a lot of money for gasoline. Okay. Which model would be less expensive over the lifespan of 1,200 or 125,000 miles? Okay. Oh boy, now let's see how we want to set this up. Okay. In the end, right, they want to know which one is going to be less expensive to follow. So I want some kind of a dollar cost for operating a hybrid versus the electric. Or I'm sorry, versus the regular. A hybrid versus non-hybrid. Okay, we're also not worrying about repairs. We're not worrying about electricity costs. We're just worried about how much gas are we spending. Okay, that's what we're doing. Let's see, we have 60 miles per gallon. And here we have 20 miles per gallon. Okay. This one, no matter what we do, we have a plus $6,000 on this thing because that's how much more it costs. Okay. And we got to run this thing, both of them, we got to run for 125,000 miles. Okay. So let's see. Assume we got to fill up the gas. Okay. So why don't we do something like this? Why don't we figure out how many gallons of gasoline we're going to need for both sides here? Okay. So to run each of these cars for 125,000 miles, how many gallons of gas will it take to do this? Okay, so what I want to do is I want to say we have 125,000 miles. This will be version 1, this will be version 2 over here. And this one, how do I just get gallons to come at the end? Right? I would do something like this. I would say this is 60 miles per gallon. Okay, so the miles are going to cancel out. I'm just going to have gallons while we're left here. Okay, so we're going to have 125,000 divided by 60. And we end up with this thing. So this is 2,083.333 gallons of gas to do this thing. Okay, second one, same idea. We're going to do 125,000 miles. Oops, just 1,000. Okay, and we're going to say this is 20 miles to the gallon. Okay, you would want to keep the 20 miles because generally you run several miles per 1 gallon of gasoline. If you run a Humvee, that might be like 2 gallons or 2 miles per gallon, but what we're pretty much doing is we're trying to figure out how many miles does it take per gallon of gas. Okay, so this is 125,000 divided by 20. Okay, we end up with 6,250 gallons of gas to run this car for 125,000 miles. Okay. Now what we're going to do is we're going to take our 2,083.33, etc. And how much was gas costing us? Gas cost $4.25, right? Dollars per gallon. Again, this is per gallon. The gallons will cancel off, and I'm just going to have how much money it cost us to run, again, assuming that you're going to run the 125,000 miles all on this gas price, which is also kind of not a great idea there. Okay, it's not really going to happen. Okay, so we have 2083 points, a couple of threes here, times 4.25. Okay. Now I put the extra threes there because I was going to just show you something at the end here. We're actually dealing with money. We're going to say, unless you actually are a gas station, you don't deal with you don't deal with tenths of a cent here. Okay. We say this is $8,554. $8,554.17. Okay, same thing with what's going on here. We have 6,250 gallons. And then we have $4.25 per gallon of gas. So that's going to cancel. We're just going to have dollars when we're done here. Okay, so that's one of the things you're doing is kind of letting the units guide you through the problem. Okay, and if you get the wrong units or you get them upside down, you know you messed up. Okay, you have to go back and fix it. But it probably tells you, like, well, I know because I got the units wrong. I know where that unit came into the problem. So that's the part I got to fix. Okay, so we have 26,000. Right, 562.5. Okay, I should have put a little disclaimer on here. Like, please try this problem yourself before you follow me do it. Otherwise, I'm robbing you of the joy of sorting this out yourself here. Now, we have a fixed cost to the hybrid because that costs $6,000 more than anything else. Okay, so we're going to take our $8,800.54.17. we are going to add our $16,000 to this thing, or $60,000. No, $6,000. 6. Oh, okay. And we're going to have the cost of running this vehicle for 125,000 miles. It's going to be 14,854 17 cents versus 26,562 and 50 cents. Clearly, this one is a lower number. Okay. Again, this is a walk before you can run sort of way to do an analysis. We're not saying that, this is absolute answer. This is the answer with what we've included in the problem so far. You want to start adding things like what is your expected repair cost? You can put that in. What is the kilowatt, cost per kilowatt hour you use to charge your car? You can start putting that in. You can start adding as many little factors as you would like to do this to make this a more realistic comparison. But for the basics, like let's just compare a very small thing before you start getting to be a bigger and bigger and bigger problem. Okay. And that's good problem solving technique. When you have a real life problem that has like a ton of different factors in it, pick your biggest one, solve it with that. Then if you need a better answer, start throwing more and more and more pieces to it, and you'll see what's going to happen. Okay. So less expensive over the lifespan, hybrid, done. Okay. I'll get to that a little bit later. Okay. So that is a genuine problem solving technique of keep things simple, and then once you have an idea of what you want to set up, you can go through and make things a little bit more complicated, more complicated, more complicated. And then there's a balance, like how long do you want to spend doing this problem versus how good of an answer do you need? Okay. So if you don't need an answer that's very accurate, maybe that was good enough. Okay. But if you need something that's more accurate, you start adding in more and more factors. Okay. So gas-powered model of vehicle requires premium fuel and has an fuel economy of 32 miles per gallon. While the diesel model averages $39 or 39 miles per gallon. Okay. Price of diesel is base price of diesel model. Oh, the diesel model costs you $7,000 more than the regular gas. Okay. Or super premium, whatever. Okay. And potential buyer notes that the cost of diesel fuel is $2.25 a gallon, and premium. This used to be the way it is. I know it's not this way anymore, but back when they made diesel trucks, the reason why they made diesel trucks was because diesel was less expensive. Okay, you're not going to see that anymore, but maybe someday. Okay. Cost of premium fuel is $2.65 a gallon. Okay. If the buyer opts for the diesel model, what would be the savings in total fuel costs over 8,000? The total fuel cost over 80,000 miles being enough to make up for the initial cost with the diesel model. Okay. So let's see here. They want over 80,000. Let's just look at it for 80,000. Okay. I think that's what they want to do here, is a kind of hinting at a break point. Okay, so let's set up for 80,000 miles. All right. Now our premium fuel has 32 miles per gallon. Is, what was it, 34? 32 miles per gallon. Okay. The diesel model is 39 miles per gallon. All right. The base price of diesel model is $7,100 more. Okay, so we have a fixed cost. Of $7,100 more. Okay, and diesel fuel is $2.25 a gallon, so fuel is $2.25 per gallon. Okay. And the cost of premium fuel is $2.65. $2 on there a gallon. Okay. If the buyer opts for the diesel model, what would the savings in total fuel for 80,000? Okay, so it's kind of a similar problem, right? That we just did. So we're going to, okay, how much does it cost to run this thing for 80,000 miles? Okay, so what are we going to be doing here? We are going to figure out, well, how many gallons is it going to take to run, right? To run 80,000 miles. Okay, so we have 80,000 miles. Again, put the one there. And then how's our efficiency? We are getting 32 miles per gallon. Okay, we have 80,000 miles for the diesel. Okay, and this is going to be 39 miles per gallon. Okay, so just how many gallons does it take to go for 80,000 miles with use of these vehicles? Okay, so here we go. We have 80,000. Okay, okay, divided by 32. We end up with, this is 2,500 gallons. Right, because the miles canceled, we have gallons. Same thing here, okay? 80,000. Okay, divided by 39. That's the efficiency here. And we have 2,051 points. What do we have here? 0.28. Okay. So how much did this gas cost us? Okay. So we have 2,500 gallons of gasoline. Okay, and we know that it's $2.65 per gallon. So this is $2.65 per gallon. Again, notice the gallons canceled. I'm left with dollars. Okay, so we're going to say 2,500 times $2.65. Okay, so this is 66.25. All right. Now let's go ahead and check out the other one. This is in dollars. All right. So here we have 2,051.28 gallons. I went to two significant figures because we stop at cents. Okay. And this was $2.25. So this was $2.25 per gallon. So the cost to run the diesel one is we cancel the gallons. Okay. And we have 2,051 times $2.25. There we go. So it cost this one, it cost 4,614. There was some change, wasn't there? 75 cents. Again, this is in dollars. Okay, so for 80,000 miles, it costs 6,600 to run the car on fuel. It costs 4,600 to run the car that's on diesel. Okay, so with the total fuel saved. Okay, we also have to add, we have to compare this, right? Is this going to add, is this going to be a difference of 7,100? Okay, so it's going to cost us 6,625 minus 4,614 at 75. Okay, so we're just going to take, I can't do the last two answers. So this is 6625 minus, I could say answer. The answer is going to be the last one that came up. So it's this one. So we should get about $2,000. Okay, so the difference in running this thing is $2,010, 25 cents. Okay. So does spending an extra $7,000 here on a diesel, right? This was another $7,100. Is that going to overcome our prices? Like, clearly not. Okay, so no. The savings in total fuel cost over 8,000 miles will not be enough for the extra initial cost, because the total savings in fuel save. Oh, they really want everything here. I think this is a less than. Okay. What did they want for the actual value here? And I kind of like the fact that they did this, but at the same time. So this was 2010, 2010, and $25 is less than a $7,000 cost for the diesel. Okay, I think that's everything we need here. Praying that it gave me one of your answers incorrect. Let's see. And find the savings of, finally compare the savings. I think that's what I did. All right. I believe that's what I had done. I'll bet this right here, because I used 51 point, I didn't use 0.28. Okay, so I will bet that's what they are complaining about. Okay, is that round off that I did. So they want us to be a little bit more precise than I was, and I'm not going to track that down. Okay, so we're not going to finish that one. Okay, because this video is long already. All right, but be more precise with it, and that should pretty much take you through the procedure on how to do a problem like this. Again, just try to set things up one step at a time. Try to make sure you're getting the right units out of it, much as significant figures, not like me, and that should do it. That should do it for this type of problem. Okay, so I'll let you go with that. And again, there is no shame in looking at your conversion factors. You don't have to memorize these things. So there you go. All right, thank you.